Welcome, everyone. If you could find your seats, please. Welcome, everyone, to tonight's panel. My name is Dr. Sulette Dreyfus. I am from the School of Computing and Information Systems here at the University of Melbourne. I am very pleased to be hosting this fascinating and cutting-edge panel tonight, The Age of Drones, How Unmanned Aerial Vehicles Are Changing Our World. I've got a number of housekeeping items first, which I have to read the long list down. So if you could please switch your mobile phones to silent. I see people frantically reaching in their pockets. The emergency exits are obviously not out the windows here. They are around the corner. If we have an emergency, if the alarm sounds, you'll be guided by the event staff out. Tonight's panel discussion will be recorded. So any questions you ask during the Q&A in the second half will be recorded, and we'll take it as your consent has been given. The recording will be uploaded to the Melbourne School of Engineering's website for general public to view, which is great, free and open exchange of ideas. The Twitter hashtag for tonight is hashtag Age of Drones. So you can turn off the volume on those mobile phones, but take them out and feel free to live tweet comment about it. I'd like to acknowledge the traditional owners of the land on which this event is taking place, the land of the Wurundjeri, and pay respects to their elders, families, past and present. Now, if I could just talk a little bit about the overview of the topic that we'll be speaking tonight and the format for it. This panel is going to explore a range of drone applications and some of the cutting edge and cross-disciplinary ways that UAV research is currently underway, particularly here at University of Melbourne. What's valuable among many other things that UAVs offer is the opportunity to remove the need to have humans in dangerous or difficult situations. So we've seen just this past winter, I'll show a really cool slide. Drones deployed to watch for sharks on Australian beaches, and eventually it's expected or reported, at least in the media, which we all know is very reliable, that drones will be able to warn swimmers or surfers of impending sharks in the area via megaphone and possibly even drop a life raft or emergency beacon to them. UAVs also help farmers manage their crops and livestock, and we'll hear a bit about that research tonight. That leads to water savings and improved crop yields. In traffic management, UAVs can help us use roads more efficiently, potentially reducing congestion and pollution. In disaster management, UAVs may save lives, particularly in fires, bushfires, fires in the city. But there are technical challenges. Unmanned systems will need to coordinate amongst themselves and work with humans in effective teams that accomplish a shared task. And there are also ethical and legal challenges to this evolving technology. I'd like to introduce our panel members tonight. First, immediately here to my right, originally from Sydney, but now here based at the University of Melbourne in the Department of Mechanical Engineering at the University of Melbourne, is lecturer Dr. Airlie Chapman. She researches networked dynamic systems, graph theory with applications to robotics and aerospace systems. She's recently authored the book Semi-Autonomous Networks. She has a PhD from the William E. Boeing Aeronautics and Astronautics Department at the University of Washington, Seattle. She's a two-time recipient of the Amelia Earhart Fellowship, and she said that one of the things that inspired her to go into this field was, quote, the beauty and predictive power of science, a quote I very much like. She is also, shy to admit, but a collector of drone comics. Dr. Ranjith Unithan is a research group leader and senior lecturer in the Department of Electrical and Electronic Engineering at the University of Melbourne. He grew up in Kerala. He became interested in drone research after working as a scientist at the Indian Space Research Organization on India's first mission to the moon. He does research in applying drones to agricultural and fire settings, and he is co-founder of Hort-Eye, an agricultural drone sensing company founded by a team here at the University of Melbourne and industry partner XM2. Professor Chris Manzi is the head of the Department of Electrical and Electronic Engineering here at the University of Melbourne. He obviously knows these two. And he's also director of the Melbourne Information, Decision and Autonomous Systems, the MIDAS laboratory, which includes academics from multiple faculties, including engineering, science, and law. Dr. Jake Goldenfein is a lawyer and lecturer at law at Swinburne University of Technology and an alumni of University of Melbourne Law School. He earned a science degree focusing on math and chemistry before moving into the philosophy of science. He became interested in drones because they provide, in his view, quote, a metaphor for the contemporary surveillance experience. He's a board member of the Australian Privacy Foundation and experimental arts organization Liquid Architecture. Welcome all this evening. So if I could just start by opening the conversation with you, Airlie, to ask a little bit about what is meant by the term distributed robotics and swarm robotics.
So that would be the title, I guess, of my topic area that I would generally work in. So I like to scale things up a little bit. It's already quite challenging to fly UAVs. We see that a lot. If you've ever seen some of the disasters that kids get up to with their toy UAVs. So I up the ante a little bit, and I'm interested in many UAVs working together to achieve a task. So that's my area, and we talk about it as a distributed task because each UAV has to in some way cooperate with all the other UAVs to achieve this task. And the network comes in when you can kind of think of it as a communication network that's been assembled by these UAVs talking to each other.
And what would be the advantage, for example, in a civilian application of having not just one UAV, but a group of them?
I think one of the classic ones is coverage. So often these UAVs individually can't travel large distances, especially the multi-copter applications. So having the ability to have many smaller ones go out and cover and continuously survey something can have a lot of advantages there. And then in disaster scenarios, redundancy is a huge thing. Our hope is that we can start deploying these in disaster relief scenarios where you expect to have some losses of vehicles, for example, in a high smoke area for bushfire recovery. And now you have that redundancy to say the mission won't fall apart just because you've lost one or two.
So it's kind of the internet of the skies in that sense.
Yeah, it's kind of like, I like that. I'll post that.
Oh, good, excellent. Maybe we could put it under one of your comics.
That can be part of the tweet. Someone can tweet that. Yeah.
What are the ways that humans and UAVs can actually collaborate on a task? And there is a growing concern, discussion you read in the paper about robots are going to put us all out of a job. So is that true? Are UAVs going to put us all out of a job? Or is there actually a need for the humans? And if so, how is that need changing?
Well, I think there's two parts to that. First of all, the cooperation element. I think that robots or any kind of automation works much better when coupled with humans. There's just a certain domain knowledge that robots just aren't going to have. I often give the classic example of a park ranger looking for a lost hiker. You can send UAVs out to look for that lost hiker, but you're going to do a lot better if you can get the park ranger to help. So just something as simple as highlighting on a map the areas that you would expect that lost hiker to be located, and then sending the UAVs in a very targeted way to find them, and then saying, no, I think you need to look more to the left, more to the right. So that kind of interaction, that marriage between robots working with humans, I think is something that's a really exciting area, and one that I think is going to be getting more and more there as we get better advances in the UAVs.
So does that mean that it will take, in a sense, some of the drudge work out of the human element of the work, but also amplify the human's ability to do their job?
I hope so. And there's certain areas where it's getting to the point it can be very difficult to get people to want to do certain tasks because of either the drudge work or because maybe it's just not as attractive a job. I think agriculture is one of the classic ones where we have an aging population of farmers. They say in the next 10 years, we're going to lose 50% of our farmers. Now, I don't know necessarily what the root cause is, but it's now requiring a single person to do that much more work than they had previously. And in mining applications, there are some that are just dangerous. So having the ability to send a UAV in ahead of time to search out the area and put that vehicle at risk rather than a human, I think really has a certain elements of what we should really be thinking of when we think of putting robots at risk and not humans.
Now, this is something we didn't get a chance to chat with before, but are the UAVs getting cheaper and cheaper? Obviously, human life is worth more than a piece of technology, but is that something that is also a factor in this? Is the price is going down, and that will make it more and more easy to use to protect human life?
I think it's a combination of having more robust platforms that are more reliable, so you actually don't lose them as often. So you're more willing to send them into those kind of areas where you expect them to actually be recovered. I think that's an element of it. I think that we're getting a lot of benefits from other industries actually helping drone prices drop. One classic one is what powers our drones are batteries. As battery technology gets better, we get cheaper and more cost-effective UAVs, which is great. I mean, we're people are pumping money into that industry, and we're reaping the benefits. So I think there's certain elements that are really helping that, and there's a general passion that people have for UAVs. It kind of inspires people to be able to see things from a perspective you can't normally see. And I think that kind of perspective is really driving a lot more hobbyists to get into to UAVs, and a lot more industries to think of clever ways to incorporate that type of technology.
So it's all those people who are obsessed by looking at pictures from Google Maps who want to actually go out and fly their drones instead to get a different view of the world.
Absolutely. How many people looked at their house on Google View?
Hands up. Who here has looked at their house on Google View?
So it's not to say you don't know where your house is located. It's because you want that bird's eye perspective. I mean,
we're all very human. Ranjith, can you tell us about a couple of projects that you find particularly interested that you're doing research in?
Maybe I can talk about two projects. I do have a couple of projects, so if you're interested, please come and see me. But I should warn you, you might be dreaming UAVs today if you come and talk to me. Yeah, so the first project is with Metropolitan Fire Brigade. We know MFB. They are doing great service to our society. There was a big fire in the chemical factory, you might have read last year. And there was also a big fire in the recycling place. So then
Coolaroo one, yeah.
Yeah, so MFB has got state-of-the-art UAV technology. So they bought off-the-shelf UAVs and some custom-made cameras. They have got thermal camera on board. They have got high-resolution images. So they get a bird-eye view by flying UAVs over an incident area. But then Will Glenn, he's the commander of UAV operation. He deployed 80 people in the chemical factory, and then they have got only voice radio, and then he could only just roll call and then check it whether they are okay. But then they couldn't efficiently deploy the crews. When you have 80 people and each of them carrying a radio, then he couldn't deploy the people properly. So then that triggered a project. So Will met me and asked whether we can develop a technology so that he can see on a display where these people are and their name is written on each dot. And then he also wanted overlapping this dot with Google Map so that they can see where they are. So then we have developed a sensor. So the sensor size is only half the size of a mobile phone that crew can wear, and then they can go inside. Then we launch a UAV, and then UAV read the location of these people and then give a real-time feedback to the commander. He can see it. So that is the first project. And also I must acknowledge my group members. They have done an excellent work, Connor, Danny and Hanson.
Okay, so so you were saying that the sensor device is half the size of a mobile phone?
Yeah, half the size of a mobile phone. Yeah, it's a battery powered.
Okay, interesting. And that potentially will save lives of the firefighters.
Yeah, definitely. So it's so that the operation will be more efficient and safe, more safe.
Okay, very interesting. And in agriculture?
So agriculture, I'm happy that my co-founders are here from Hotai, and I appreciate their enthusiasm. Yeah, so that is how drone technology is helping farmers to improve the yield and reduce the damage of the crop. For example, if you are a farmer and you have got, say, 500 hectares of vineyard or citrus plantation, then you want to check the life of the plants, and then whether there is any disease or whether you have under-fertilized, over-fertilized, or there is any water stress, then we can come with our sensor, we connect it on the drone, and then we fly it. So we are using multispectral camera. So the advantage of multispectral camera is the features that we are looking at might not be visible to naked eyes. So human eye might not be able to see, but we can detect these symptoms a bit early so that the farmer can do some intervention and then prevent the crop loss.
So this is a UAV flying, let's say it was at Orange Grove, I'm just making this up, but if you've got 1,000 or 2,000 hectare farm, you have the UAV flying over the top and it is able to ascertain some sort of pest or other on the crop before a naked eye would be able to pick it up.
Yeah, so then, for example, this sensor has got 6 or 7 tiny image sensors. So what we are doing is we will be taking around 7 or 8 images of same scene at different wavelengths or different colors, and some are in the visible region, some are in the infrared region. So if it is a healthy plant, healthy leaf, if you take a healthy leaf, what happens is it absorbs visible light because of the pigments like chlorophyll, and then it reflects infrared light that we can't see because of the cellular structure. So if something happens to the cellular structure or something happens to the pigmentation due to some fungal infection or due to some reason, then we can get that information from these all images. So we fly the images so that it's an autopilot. It will go in a serpentine path and image it, and then we can combine all the images in the algorithm and then we process it. Then we can find out where these issues are, and then we can kind of give the information to the farmer.
But the farmer doesn't actually have to sit and look at this on screen. It's actually a feedback that will happen automatically about where the risk areas might be.
Yeah, so we will be providing that information. So we will image it and we collect the data, then we get the useful map, and then we will be giving the feedback to the farmer.
Fantastic, very interesting stuff. Just a question on the fire risk, because this is quite interesting. I would assume that a UAV has a different tolerance for heat than a human being does. What sort of difference is that, even in a full get-up gear that a firefighter might have?
Yeah, so in our first project, heat is not a problem because UAVs are flying maybe around 50 meters above the area. 50 meters 50? Above. Yeah, so that is not a problem. But if you are developing an autonomous drone, that is another interest of Metropolitan Fire Brigade. So when there is a fire, they want to just put in a drone and get so many images and get it transmitted wirelessly so that the crew can plan how to manage the situation. Mm-hmm. Yeah, so in that situation, yes, there is a big challenge because at the moment, most of the UAVs are made of plastic. It can melt it. However, last year there is a research group in Korea. They came up with a UAV that they covered with ceramic some fiber, mm-hmm. and then that can protect heat entering into the drone. So people also use some kind of reinforced carbon materials. So such materials are there. Then we also do some work on autonomous drones. So in our design, what we do is we are covering with this special kind of fabric around the drone and the sensors, and also we put a thermal sensor so that it will not go into the fire. So it will stay away from the fire.
But does that mean that it could go into, for example, not just above a bushfire, but in a very hot building, like a burning building?
Yep, it can.
You can.
Yep.
Very interesting. Very interesting.
Yeah, because this fiber is already used in the MFB's jacket, and even in military they use it. So that can withstand, I think, around 500 degrees. 500 degrees. Yep.
Celsius.
For a couple of minutes. Yep.
Wow. Okay. Hotter than my bath, that's for sure.
Yeah.
Can you? Now you've co-founded this drone-based company. What are you trying to do with it? What are its aims?
Yeah, our aim is helping farmers, as I said, to increase the crop and then help them to reduce the crop damage.
Mm. And do you have some surprising experiences from your research, luck, serendipity, things you weren't expecting when you started doing research?
Oh yeah, the UAV, when I heard, because of my aerospace background, I was planning some project in the line of defense, because that is the first thing come into my mind. But then later I realized UAV got so many applications in civilian area. Mm-hmm. So then UAVs are actually, UAVs can be in friendship with us, not only to military people. So there are plenty of applications. Maybe that is one of the important thing or interesting thing for me.
Mm-hmm. Mm-hmm. Very interesting. Chris, if we can move on to you, can you tell us a little bit about some of the challenges that researchers need to deal with moving from remote-controlled to autonomous operations in terms of human-machine interaction?
Yeah, so I think Ellie kind of touched on this a little bit already, but there's a number of open questions around how much autonomy is the right level of autonomy to give any autonomous vehicle platform. In domains, for example, like autonomous driving, there's a great deal of research that shows as you increase the level of autonomy that's given to the vehicle, you can reach a tipping point where, although you're introducing driver aids, the overall operation of the vehicle becomes more unsafe because the driver isn't devoting enough cognitive load to the tasks that are remaining to them. So in the context of a UAV, where it's really being used for either data collection or delivery, what you would ideally like to do is have the human devoting the right amount of cognitive load that enables the data to be gathered efficiently and effectively, or the packages to be delivered efficiently and effectively, while freeing up the human operator to do other tasks. So one of the challenges is, I guess, with a remote-controlled drone or remote-controlled vehicle, you're essentially devoting your entire cognitive load to
your joystick.
Yes, exactly. Whereas there may be opportunities to do other things. For example, if you've got, you picked on the shark spotting application.
Gotta get an opportunity to put that picture back up.
But having a single person or a single lifeguard controlling a drone while they're looking for sharks in the water may not be as effective as equipping a drone with the ability to do machine vision and just alert the operator when they've spotted a shark-like object, and in the meantime the lifeguard can be monitoring the beach for swimmers in trouble. So it's about leveraging the capabilities of the human in the most effective and efficient ways.
And not giving them cognitive overload.
Indeed, indeed. So I guess the other example would be if you're exploring a collapsed or damaged building, you can't afford to have someone standing in a corridor looking at an iPad interface and directing the drones where to go while smoke is filling the corridor and putting them in a potentially dangerous situation.
So how is that going to work in terms of coordinating large numbers of autonomous vehicles? I mean, that is a tricky task. Hard enough with one, but if you had 10 or 20.
Yeah, so that's why we recruit really smart people like Ellie. But essentially, you can think of there's two elements to the system. One is the human, and the other is the autonomous system that may be made up of one or multiple drones. Those drones will need to coordinate amongst themselves to a degree to accomplish a mission or an objective that's given to them by the human operator. So the human might say, explore this region of space. How you guys or how you drones do it is up to you. You need to coordinate amongst yourself, exchange information amongst yourself to explore that space effectively.
And what do you do when you have a sort of complex variable thrown in? So, if you have UAVs that are flying in three-dimensional space, they're moving around, and a gust of wind comes along and is pushing one of them out of formation. How do you deal with something like that?
Yeah, so that's about the vehicles themselves, or the UAVs themselves, being able to respond to disturbances, and if they're continually communicating amongst multiple agents, they can account for the fact that a disturbance has occurred, readjust their positions, and I guess, compensate for
Like a
things
flock
that
of
have gone wrong.
birds coming together.
Exactly. And I guess the idea is that they alert the human operator for a high-level command only when absolutely necessary.
How pervasive is domestic UAV use?
I guess there's probably the audience can answer that as well as I can, but
I'm hoping for a house cleaner that'll come along and do all my floors.
Well, a UAV might not be the most effective way to do that.
Maybe a Roomba?
Maybe.
We got to get covered.
I've heard they don't work, unfortunately,
look,
sadly.
We're seeing more and more applications of autonomous vehicles as time progresses. Ranjith has touched on a couple of domains, but other examples are in surveillance of power lines, for example, where we can send. So at the moment, Victoria spends about $90 million a year monitoring vegetation ingress into power line areas.
And that's because obviously overhanging branches may lead to bushfires or create a bushfire risk.
Exactly, and King Lake's a good example of that. So if we can, instead of having $90 million of people in utes going out
Is
and
that
monitoring.
what the surveillance currently is? Is it literally guys in a truck who go climb a pole?
Yep, or helicopters, or but if we can send UAVs or multiple UAVs along power lines, monitor the vegetation, have data analytics running in the background that can predict how the vegetation is likely to ingress over the next sort of couple of months, then we can selectively deploy human resources to account for those types of scenarios.
Are there other humanitarian examples you can think of that would be, UAV friendly?
Certainly, yeah. So things like after natural disasters, UAVs are a fantastic tool to be able to very quickly do things like mapping out disaster areas, searching for survivors, retaining a communications infrastructure in an area that possibly has lost mobile phone coverage. We can restore that.
So how is that done, the restoring of the phone coverage?
So you essentially use the UAV as a mobile base station, and if you send up a network of base stations and have them communicating, yeah.
I think they used that in Puerto Rico actually recently.
Yeah.
They currently have one. They call the flying cow actually.
Okay.
A cell in the air basically, and I think it's about 30% of people don't have mobile phone coverage at the moment, and it's actually much more effective than putting up a temporary towers to actually use these kind of comm-based towers.
Yeah.
And do they just bring them down to replace batteries, or you put a spare up and the tired one comes down for a recharge?
Yeah, so it's effectively, yes. So this is again where the coordination aspects start to come into play, it's. But I like the flying cow. It's much better than a flying pig.
Have you seen students or sort of younger generation researchers adopt UAV technologies in new and interesting ways?
Yeah, so I guess any master's student project that involves UAVs has a lot of interest from our engineering cohort. They jump on board. We've run competitions. The Outback Joe competition is a search and rescue competition where a UAV needs to go and find a person in
A lost hiker.
a lost hiker. There's UAV racing, all sorts of applications.
And do you find things like the competition are very well subscribed? There's a lot of enthusiasm for it from among students?
Students love competitions, I think. And,
Very good, very good. Jake, if I could ask you a couple of questions more about the ethical and legal ramifications of this evolving technology. What does the combination of drones with machine vision systems look like in the future, and what is going to be the sort of evolving legal questions around that?
That's a good question. I suppose we have to talk very quickly about machine vision and then talk very quickly about drones, and in order to understand what the significance of their combination might be. So I suppose the history of the photography of persons in particular has always been preoccupied by two questions. What person is that? And what kind of person is that? Those two questions have always sort of orbited each other throughout the sort of the whole history of photography. The photography was like a tool by which persons could be examined scientifically. You could produce taxonomies. You could compare people, and in the end, you get these sort of anthropological and criminological ideas around photography. And the sort of most classic example is of Francis Galton, who was this eugenicist really, but a cousin of Darwin's, who in the middle of the 19th century says, I've got this idea about what photography can show me. I'm going to sort of take this register of portraits of criminals, and I'm going to do multiple exposures such that I can sort of generate a photographic mean, right? Produce a profile of what a criminal person looks like.
Okay.
Right? And he does this, and he said, you know what? It was a failure, of course. It was a failure. And he said, this exercise ultimately produced an image that exposed the common humanity and all. Very nice. But that idea hasn't really gone away. And now when we think about machine vision as applied to persons, we have systems that detect affect. Right? Well, we can answer this question: what person is that? We have biometrics that do that better and better all the time. But we also now have systems that are getting better at answering what kind of person is that. So they detect affect. Are you happy? Are you sad? But they also can detect other things. For instance, there was this research that came out of Stanford where using training data from a dating application, a machine vision system using machine learning could quite accurately predict the sexuality of persons that were in the photographs. So now we have effectively a system by which we can ask a machine learning system any question we want about a person, if we can find the data that will support it, and it'll give us an answer in terms of inference, a probability about this. So it might not just be sexuality, it might be IQ, it might be political leanings, it might be propensity towards deviant behaviours, etc. So Francis Galton in the 1860s was kind of doing like a proto-machine learning thing, and now we've actually got the technology that's doing it a lot better than he could do it. Maybe he just sort of, he just couldn't see it. But what the machine learning system now says is, well, there's actually a lot more information in the human face than even humans are capable of recognizing. So we now have a technology capable of identifying a person and potentially certain characteristics about a person, profiling a person, on a mobile sensing device. All right, so that's the machine learning part of it. So it's combination with drones. So I suppose you said my interest in drones is sort of as a metaphor for contemporary surveillance experience. So rather than drones, like material UAVs per se, I suppose I'm more interested in the idea of like drone logic, right? The ideas of remote sensing, the fact that most of us have smartphones in our pockets that are operating as sensors at a distance remotely for the benefit of another entity. So in a sense, we're all kind of drones, or we're being droned. It's these things that happen in the background. So that's this remote sensing is part of it. But then because of the sort of physical manifestation of the drone and its sort of encroachment into physical space, you're faced with this idea that we have not only sort of data retrieval, sensing and processing happening remotely, but also the capacity to act on the world. So the drone then becomes a surveillance metaphor for the idea of data collection, data processing and data action all located within a particular system. So when we combine these things together, we have a technology capable of interpreting a person, identifying and making interpretations about a person, and then acting on those interpretations according to whatever program is decided. And that has a lot of applications, I think.
So can I ask a sort of a very basic question now about rights to privacy as they do exist in law, or maybe should exist in law? You're sunbaking in your backyard, you're starkers because it's your backyard, you're enjoying the sunshine. Your neighbor's flying a drone, they take some interesting photographs of you, but they aren't on your property, or they aren't even hovering over your property.
Doesn't really matter.
Doesn't really matter. What happens if they're flying their drone over your property?
So,
Are there any protections yet?
Okay.
Has the law caught up with technology?
the law doesn't necessarily catch up with technology, but I'm going to be really coarse, right? Because the answer to your question kind of depends on whether the images captured include the genitals and anus.
Okay.
Because there's a criminal provision in Victoria that says you are prohibited from using a technological device from viewing the genital and anal area of a person. And if you recall, this comes from upskirting at the Australian Open, which was this, this thing, people putting cameras under bathroom stalls. But it's not framed in terms of that specific situation. It's a general criminal prohibition. So there is a criminal prohibition specifying that if you've got a camera pointed at the genital or anal region of a person, then you are liable for a criminal offence. But privacy is a different question.
So essentially what you're saying is the law is not providing a protection of privacy from a drone flying overhead or from invading your privacy that way unless the content is something that would offend in that way.
Well, no, not even. It has to be that specific because we have surveillance devices laws in Victoria that says you're not allowed to use a optical surveillance device to record a private activity without consent. What's a private activity without consent? Well, it doesn't include anything that's outside of a building. So if the drone is on outside your property or above your property, if it's filming you nude, there's no prohibition under that Surveillance Devices Act. If it's an individual operating a drone, then they're not subject to the data protection regulation in Victoria or Australia, and we don't have a tort for invasion of privacy. If they capture these images and pass them on without consent, there's potentially you could make a claim on the basis of the equitable action of breach of confidence, but I would be very interested to see if that actually would ever happen.
Has the increasing spread of UAVs and private use of them led to a flood of concerns and complaints to privacy commissioners around Australia?
Yes, absolutely. And there's been numerous reports and there's been, sort of attention promised to it. I think that, to be honest, pushing privacy regulation in Australia is a very difficult job, and it doesn't work very well. So I think the strategy with respect to drones has to sort of been to foist some responsibility onto the sort of the aerospace regulator, who's required to ensure sort of the safety of drone operation. But that doesn't really include sort of privacy of persons that might be captured by images.
And finally, who is exactly at risk, or who is liable if we're going to have swarms of driverless cars and they start crashing into each other all the time, just say, who is liable for that? How will that work?
Well, that's something that's being worked out now. I think that it's the insurance lawyers who'll be able to give you the best answer to that question. In reality, they're the ones who are going to be most interested in working it out. But ultimately, these systems, autonomous systems, at some point somebody sets the parameters for what they're supposed to be able to do. So what we do need is a new understanding of how tortious liability or other sorts of liability might work and its relationship to foreseeability, based around the concept of parameterization and whether or not you've audited a system to the extent that something going beyond the parameters of what you expect it to do, it becomes unforeseeable. And to that extent, it does slot relatively frictionlessly into existing common law liability understandings, but there's just going to be a lot more parties involved in working these things out, and some of them, won't be parties that are local. The data and the computation running these vehicles is not necessarily going to be endogenous to the vehicle. It's going to be within distributed systems, and who governs those distributed systems and who's responsible for what happens in those distributed systems is a really interesting question.
So I think, Ranjit, we had a conversation earlier where you were mentioning both what Amazon was doing with UAVs in the UK commercially, and also a project that was starting in Dubai about moving people. Can you just tell us a little bit about that? Because that has some interesting implications, I think, as well on the societal front.
Yeah, I think you might be aware of Amazon is planning delivering your parcel using drones. So it's called Prime Air. So they have a separate arm within the Amazon. So at the moment they are doing testing in UK. So you can see videos uploaded by Amazon on their webpage under Prime Air. So what Prime Air does is you order an item, if that is around 2 kilos, then a drone will deliver you the product within 30 minutes. And then they can track where it is going, where is the UAV at the moment, and then dropping parcel in your backyard, and then take off and then return to the Amazon launching pad. They got drone pads. And then in Dubai, Dubai I think is very interesting. Dubai I think they wanted to be at the forefront in the drone technology, but their interest is passenger UAVs. So this year they started in March. So that's a small
UAV. Call
UAVs.
it? Passenger UAVs.
Yeah, UAVs, and then it can carry a person weighing up to 100 kilos. So it's an autonomous vehicle. I don't know how it is working, but they got the vehicle, they bought it. At the moment they are doing the safety studies. So you can get into the passenger drone, then just press your destination. That's all, it will take you there.
So is this a world in which I can Uber drone my child to primary school in the morning? and a robotic mother kitten will come pick her up by the scruff of her neck and fly her to the start of her school.
Yeah, I think something like that. Maybe in future you may have another app, passenger drones. You can call passenger drones. There will be some dedicated locations where you catch a drone and go home.
Jake, if I can jump though, we've seen some media reports about the much hype UK Amazon UK project that has been around the fact that Amazon is collecting information about you when that package is delivered. So if you show up in your tatty jammies at the door, if you haven't kept your front garden to the standard that one would like, you may soon find that there are ads appearing on your email or whatever else for where there are great places to buy pajamas. And who can come and garden for you for your front garden, and here's a home watering system. What are the implications of that for people who want the service of the UAV but not the intrusion of this sort of spying and data collection that might come with it?
Well, that would be nice, wouldn't it? I've lost my microphone. Generally, by using the service, you're going to consent to the contractual terms which govern things like data collection. So, in certain respects, you don't, and this is often talked about in terms of consent. Well, you consent to your data being collected this way. It's not really consent because you can't use the service otherwise. It's not true consent unless you're happy to wait a few weeks for things to come by ordinary post rather than the cool drone.
Well, we've all read the full privacy, disclosure contracts
absolutely.
From beginning to end.
Absolutely, and just like the system, there's more information in a human face than a human knows that a computer can tell us. Well, there's a whole lot of information with respect to how your front yard looks, commercially valuable information. That these systems can work out, the data processing that can ultimately work out. So why wouldn't you work it out if you've got the opportunity to. I mean, this is the commercial logic. Yeah.
So I hope that's triggered some thinking and inspired you to come up with some creative questions. I'd like to open the floor to questions now. If you want to just put your hands up. Yep, just here in the front, the gentleman.
So the UAV delivery services, the Uber drones, the Dubai drones, the weakness in all of it is air traffic control. So when are we getting decentralised air traffic control that'll let manned and unmanned aircraft fly in the sky without hitting each other?
Can you guys organise that by next Tuesday?
So I think the catch there is it's the mixed manned and unmanned operation, and that's challenging not just in air traffic control. It's a real challenge in, for example, autonomous mining. We've seen Rio Tinto has implemented a fully autonomous mine site. Humans aren't allowed in there. One of the stumbling blocks for autonomous vehicles is going to be how an autonomous vehicle operates with non-autonomous vehicles on the road, and that interaction is going to depend on geography and the kind of unwritten road rules that apply in different jurisdictions. So it's an excellent question. It's not one that we will have answered by next Tuesday, but yeah.
I think a step in the right direction is Digi, which is one of the largest UAV producers. They're the sort of the very white UAVs that you probably see flying around. They've now started creating, what's the acronym? ADS-B receivers, which can detect other UAVs that are in proximity that have them on board. So they're usually on commercial size crafts, but their next step is to also have them on board. So it's no longer now a visual detection system where you have to actually see another UAV in close proximity to avoid it. You can get a heads up ahead of time, and at least making those positions digital where you can actually, so the information that is on board is they broadcast their current position, their heading, their speed, and if there's any kind of safety issues involved, if they're, if there's an emergency or a dangerous situation where they may have to land. And they usually send that down to a cell tower, which the hope is that that becomes automated in the future. But at least we're starting to get that type of sensing device and broadcasting device on these smaller vehicles. So that's helping solve the problem, but yeah, not by next Tuesday.
And probably the other, point to touch on is you very rarely see birds collide in a flock. So it does point towards you don't need a centralised air traffic controller to be able to do collision avoidance in those types of scenarios. So.
But in the mixed one, you would end up with an autonomous. So people would actually log. People will log their trips into the central system, and the computers would log them into the same system. You're going to end up with a centralised system eventually, aren't you?
For the air traffic control?
Mixed mode air traffic, yeah.
So I guess it depends. I think it can be decentralised to a large extent, but we will see.
Road rules. Road rules.
Road
are classic.
rules.
Yeah, road rules for UAVs.
Yeah, road rules. There is a hand just way down the back there, the gentleman with the two hands up. Yes, that's you.
Yeah, g'day. Look, I'm up in the fire-prone area in Cockatoo, and I'm just wondering how long before I start lobbying the local CFA to invest their resources in drones, deployable drones with possible heavy lift capacity rather than trucks.
Yep. I think, yes, MFB is always thinking of the best solution, best technology. So they are doing actually a great work. They have got a couple of visionaries. They already thought about in the same line. So they wanted to actually deploy a drone to the area before the trucks reach there. So then the drone can't do many things, but drone can take images and they can understand what extent some building caught fire or whether somebody is there with a gun, so they can assess the situation and send the truck and the number of people accordingly. Yes, they are already thinking of such a system, but then the problem is again the autonomous drone. So there are two aspects. One is autopilot on the drone. Autopilot is using a mobile phone, like using a drone deploy. If you buy a DJI drone, you can download and you can set the path. It will go through that path. and then return home. That is autopilot. Then is one another aspect is collision avoidance. So if there is something is obstructing, then you should avoid that one. So if both are there, then yes, MFB can use this one.
But can I just ask it for clarity? That's for, say, knowing where a fire is and potentially communicating back. So, for example, if we had in the bushfires up at Marysville, you might have been able to give better information to people to make more informed choices to stay or go.
Yep.
But is it a reality that drones would be able to carry water, for example, in large quantities, or other things that might help actually quench the fire?
At the moment, MFB is only thinking of taking the images and then finding out the temperature. But then there are some heavy UAVs that can lift up to 30 kilos or 40 kilos of weight. Maybe that can carry some kind of chemicals and dump it on the fire. Yes, that is possible. With current technology, that is possible. Like XM to one company, they are developing a big drone that can lift maybe 40 kilos.
Mm-hmm. Interesting. Other questions? I will come just a second. I want to just take, no one from this side has any questions? Yes, just down the front.
Thank you. My perspective on this is from weather. With the aviation industry, I don't know how many 100 years ago or whatever, the Bureau of Meteorology probably wouldn't have been about a tenth the size it is now if it wasn't for that. So does drones have the... do you think that will have the ability to increase resources in this type of area, or
As in, you mean make better predictions of weather? Or?
Well, actually, that too. I was looking at this thunderstorm in the back there. I think how cool it would be if some drones were up there. You can measure some really cool things there, or even just temperature profiles or humidity profiles. There's a lot of cool things you could do. But so far, I haven't had much discussion about the weather, so I was going to put it to you guys. What do you guys think?
Is that going to be something that's going to be a recipe for better prediction, maybe more micro prediction for microclimate impact as well, and forward projection?
I think that they're starting to do long endurance fixed wing aircraft. They can actually now, for fixed wing, large wingspan, where they basically take these, we're talking large wingspan, so the larger scale would be wingtip to wingtip kind of large wingspan.
Window to window.
Window to window for wingtip to wingtip. And you basically cover the wings with solar panels. And with that scenario, you can actually keep them up there for months, years is the speculation, where you just bring them down for maintenance. And the idea is they fit this beautiful midway point between that high coverage satellites, which unfortunately have return times, and the low point where you have people going around putting samples of water, things on the ground. And it has a much better return time. You can send it to areas where you need that information fast. So for example, hurricanes coming in on all kinds of disaster areas. But it actually has this beautiful midway point. And then on top of that, if you wanted to, you could strap some comms things on it too and have better mobile phone coverage. So it is something they're looking at. And that scenario, the autonomy has to come in, because you're not going to be getting somebody sitting there looking at a very dreary, very slow moving, effectively like a glider for months on end. It's definitely something people are looking up, and it's something that they have spent very long endurance times on fixed wing aircraft.
Can I ask, how robust are they physically if they're going to go into a thunderstorm?
So what they actually do is they often sit above that. So some of them are actually very high altitude. We're not talking, so often what we've been talking about here are the images of what we see when we think of UAVs. We think of these quadrotors that are bothering us at the beach. This we're talking about, you just don't see them. Like you wouldn't even know they're above you. In a way that they're sensing weather and not sensing you. So there's a whole spectrum of that, and then a lot of the challenges are just getting this very lightweight material, long endurance flight, but it's and you can do all kinds of things like take advantage of the updrafts that occur naturally in the atmosphere to give yourself energy harvesting techniques, and you get inspiration from bird flight to see how they do this kind of harvesting, because you can get albatrosses that stay up in the air for months at a time. So it's actually for at least a bio-inspired feature. It's a kind of, it just is a way to dream, I think, is a
Perfection of science.
Yes, exactly. Perfection of science. Thank you.
You just had a question here in the front. Yes.
So we've heard about drones for good. What about drones for evil? And drones be used for weapons of mass destruction. Can drones be used for biological hazards? Are defence using drones at the moment for their tactics?
Throw that open to the panel.
I think they potentially can be used to counter. So the best counter to a drone is probably another drone. So it's important to stay one step ahead, and you could envisage situations where if you had an offensive drone, a defensive drone would be the best option.
Jake, do you have some comments on that in particular you'd like to jump in on?
Look, not necessarily. I mean, when the Iraq War started, the US military wasn't using a lot of robots, but sort of by the end, they were using thousands and thousands of them. And they do all sorts of things, and they, including carry very big guns. But who those guns are pointed at, or who's sort of behind the guns, these are political questions, right? And the laws of war don't tell us that we can't use these things. And I think the idea that autonomous weapon systems should be banned is a little bit sort of not just naive, but a bit sort of insensitive to the vast range of things that they might do. So yeah, I'm not an expert enough to tell you whether the regime of the laws of war is sufficient to ensure that we can subject these weapon systems to the right level of control. I know that the focus of weapons review under these international treaties is whether or not they are sufficiently discriminating, right? They're not indiscriminate weapons and they don't cause unnecessary suffering. And to my knowledge, there haven't been drone applications that have failed that very publicly. So people talk about it as an ethical question. I don't really think about it as an ethical question. I think it's a political question. It's like a geopolitical question. Yeah, I think they absolutely could do evil, but there's lots of big bombs that do really bad things as well. If a human operator puts a gigantic bomb in an area, it's going to destroy everything there. If you put an automated weapon system, it might do the same thing. I'm not sure why one is so much worse than the other.
So we put that on the agenda to solve for Wednesday now, right?
Yeah.
Yes, just here.
So how do you build graceful degradation into your aerial systems? So you have Amazon flying around homes. How do you deal with your various modes of failure?
I guess you have common sources of failure, and you have a fallback system that accounts for the reduced capability of the drone under those fail cases is probably the glib answer. So yeah, you have to envisage what can go wrong and then have systems in place that account for it.
Including presumably additional drones to do backup.
Oh, potentially it might be if you've lost a certain amount of lift in the drone, then the graceful degradation is you just land it wherever it's safe to do so. You don't try and fly or continue to fly, so it's not dysfunctional.
I might take one last question and then, yes, sir.
So on the back of that previous comment, I might have a more apt name for your internet in the sky, Skynet. But on a serious note, how much demand is there for low-powered computation on these drones for local processing?
Yeah, well, Ranjit is an expert in that. Do you want to take the first crack?
Yeah, I think the computing power is a big issue in the drone technology. So when you want to develop autonomous drone, then you need so many sensors fitted to the drone. Then the sensors are giving you enormous amount of data. Then you need powerful algorithms. Then you need very good onboard computers. So then yes. So at the moment when we did some work on the autonomous drone, what we did is all these sensors are getting the data. Then we transfer the data to our desktop, and then we run SLAM type of big algorithms, and then only get the commands and then passing on to the onboard computer. That's what we do.
So local onboard processing.
Yeah, that is
quite difficult.
difficult. Yeah,
But it also lends itself to heterogeneity within a swarm of vehicles. So there's no point every UAV being necessarily equipped with a vast set of sensors, all doing a huge amount of computation on board, because it's just not efficient from a power consumption perspective. So in many situations, you're actually better off distributing the capability across a number of vehicles and distributing the computation across a number of vehicles to reduce the power consumption, which in turn reduces the battery requirements and can reduce the weight.
And how long they're in the air for.
Yep.
I think we have to wrap up. It is just on 7 o'clock, but I know our panelists will be hovering around here afterwards.
Was that deliberate?
Yeah. Hovering around, and I'm sure as Early laughs, she'll show you her collection of Joan comics. But by all means, come up and talk to the panelists afterwards if you have specific questions. I would like to thank all of you tonight, Early Chapman, Ranjit Unathan, Chris Manzi, and Jake Goldenfein, as fantastic panelists. I hope you guys have enjoyed what they've shared with us this evening, and thank you very much for coming along.
Thank you.